Welcome to today's demo from Introspect Technology. Today, we're focused on the SV3 MIPI D-PHY generator for receiver testing. And the topic for today's session is the CTS Colorbar. This is a test pattern that is defined by the Conformance Test Suite of the MIPI Alliance. And we describe the properties of this colorbar and why it's important for receiver testing. So the hardware setup for today's session is illustrated here, where we connect the SV3 D-PHY generator. This is a very compact 4-lane MIPI D-PHY generator that's capable of producing both protocol layer as well as electrical layer test parameters. And for today's session, we connected to the oscilloscope in order to illustrate the importance of the CTS Colorbar. So we'll go ahead and start the software here. By default, the MIPI D-PHY generator is programmed to create a D-PHY colorbar pattern, and the colorbar pattern that it actually is creating is the CTS colorbar pattern. And we have already executed this test and running it on the scope, and we'll show the properties of the CTS colorbar pattern and why it's useful for receiver testing. So this is a scope view of the output of the SV3 D-PHY generator, and what we're showing is really one packet out of the colorbar pattern that's being produced. And you could see already just at this scale of zoom that the colorbar pattern has a mix of different frequencies on the line, and that's one of the properties for the pattern that makes it useful for receiver testing. For example, if I zoom in onto the central section here of the pattern, I could go in and see what the pattern looks like. And so you could see with reference to the colors on the waveform here, the yellow is channel 1, so that's data lane positive, and the green is channel 2, which is data lane negative. And so what this section of the pattern does is really it's transmitting a 0 in a sea of 1s, and that's a good test for for receiver stress testing, especially as we inject jitter and DJ onto the line, is to make sure that the receiver is able to to detect an isolated negative going pulse, as we show here. If we zoom into other sections of the pattern, like towards the end of the packet here, and just say zoom in there, you'll see that it's the opposite now. It's a single positive 1, so the positive lane is all zeros and a positive 1. So it's a 1 in a sea of zeros, and again, that's the opposite, that's the complement of the previous test, showing the ability of the receiver to detect a single lone pulse in a sea of zeros. Similarly, if we go to other sections of the pattern, towards the center of the pattern in particular here, basically what this is really a high frequency pattern. So it's a 1010 pattern. So the CTS colorbar pattern is really a mixed frequency pattern that has properties that make it useful for isolating and stressing different aspects of the receiver when it comes to electrical testing. At the same time, it is constructed like a frame, so it has a frame start and a frame end packet and can produce an image preview that is perceptible and that is protocol compliant. So if I click run again on the software here, and with the preview image generation enabled, I should be able to see a real image. This is a real picture, so it's both compliant at the protocol level, at the CSI2 protocol level, as well as at the electrical level as well as having good electrical properties for stress testing the analog portions of the receiver. So this is an actual complete image that's completely valid. So that's a brief overview of the CTS colorbar pattern and why it's useful for receiver testing.